Right now, somewhere in Canada, a Chinese electric SUV is shaking itself so violently that it looks like a dog shaking off water. Seconds later, every layer of snow slides off the windshield, roof, and hood. The car just cleaned itself. The incredible part is, this isn't a concept car. Thousands of Chinese EVs like this have already been legally sold and are driving on Canadian roads. Yet just across the border, American buyers can't buy them. But even that wasn't what shocked me the most. Another Chinese EV costs just $16,000. When it runs out of battery, it doesn't wait to recharge. A robot replaces the entire battery pack in about 3 minutes. And this isn't an experiment. That battery swapping network has already completed over 100 million real-world battery swaps. And that's only the beginning. One Chinese sedan can spin 360 degrees like a tank. Another has no rear window at all. Another produces 1,300 horsepower, more than many million-dollar supercars. Each one breaks another rule the auto industry once thought couldn't be broken. At first, I thought this was just another list of crazy Chinese cars. But the deeper I looked, the more I realized these cars weren't the real story. They're evidence of something much bigger. So why are thousands of these vehicles already on Canadian roads, while America is still keeping them out? That's exactly what we're about to find out. The car that changed my first impression. The first time I watched the ET9 shake snow off its entire body, I thought it was nothing more than a clever marketing stunt. After all, every automaker releases flashy demonstration videos. But then I realized something important. This feature wasn't designed to impress YouTube viewers. It was designed to solve a real problem. Anyone who's lived through a North American winter knows the routine. You wake up early, walk outside in freezing temperatures, and spend several minutes scraping snow and ice before you can even begin driving. The ET9 approaches that problem from a completely different direction. Instead of asking the driver to remove the snow, the car removes it itself. That may sound like a small convenience, but it represents a completely different philosophy. Instead of simply building a better car, engineers asked a different question. What if the car could eliminate one more annoying task from your daily life? That's a subtle shift, but it's also a powerful one. The technology behind the ET9 isn't really about snow. Snow is simply the demonstration. The real innovation is the vehicle's active suspension system. Each corner of the car can react independently, constantly adjusting itself hundreds of times as road conditions change. That same system can also generate controlled movement throughout the vehicle's body. Removing snow just happens to be one creative use for it. And that's when my first assumption completely changed. For years, many Americans viewed Chinese automakers as companies that copied what everyone else had already invented. But copying doesn't create features like this. This wasn't another cheaper version of an existing luxury sedan. It was an entirely different way of thinking about what a car should actually do. And that realization led directly to an even bigger question. If this is what Chinese automakers are building today, what else have we been missing? The $16,000 car that changes the rules. When most Americans hear the phrase Chinese EV, they usually expect one thing: cheap, basic, low quality. That's exactly why the Firefly is so surprising. Its expected starting price is around $16,000, less than the price of many used sedans in today's American market. Normally, a lower price means sacrificing performance, technology, or convenience. But Firefly challenges that assumption. Instead of competing by adding a larger battery or a bigger motor, its biggest advantage comes from removing one of the largest frustrations every EV owner knows: waiting. For years, the electric vehicle industry has treated charging time as an unavoidable compromise. Fast charging became faster, batteries became larger, But drivers were still expected to stop and wait. Firefly asks a completely different question. What if you never had to wait at all? Imagine pulling into what looks like an ordinary service station. Instead of plugging in a charging cable, you simply drive onto a platform. The car positions itself automatically. Seconds later, robotic arms move underneath the vehicle. The depleted battery is unlocked and removed. A fully charged battery slides into place. The entire process takes about 3 minutes. That's not just faster than charging, it's faster than buying a cup of coffee. More importantly, the driver leaves with a 100% charged battery, not an 80% fast charge that still requires additional waiting later. This completely changes how the car is used. Instead of planning trips around charging stations, drivers simply exchange energy and continue driving. It's a subtle difference, but one that fundamentally changes the ownership experience. At first, battery swapping sounds like a clever feature, but the more I looked into it, the more I realized the car isn't the real innovation. The network is. A battery swap only works if thousands of batteries are already waiting, if robots are operating around the clock, if software knows exactly which battery every customer needs, if logistics keep the entire system running without interruption. That's why the number that impressed me most wasn't $16,000. It wasn't even 3 minutes. It was this. More than 100 million battery swaps have already been completed, not in test facilities, not during demonstrations, on public roads, by everyday drivers. That changes everything. Because once a technology reaches that scale, it stops being an experiment. It becomes infrastructure. And infrastructure is much harder to compete against than a single product. The car that drives like software. Then I came across another Chinese EV. On paper, the headline was obvious: 1,300 horsepower, enough to outperform many exotic sports cars costing several $100,000. But horsepower wasn't what caught my attention. What happened next did. The car rotated 360 degrees in place like a military tank. No drifting, no complicated maneuver, just a full-sized luxury sedan spinning effortlessly within its own footprint. For decades, engineers accepted certain physical limitations. Large cars needed large turning circles. That was simply part of automotive design. Apparently, not anymore. The secret isn't raw power, it's control. Each wheel is driven independently. Each motor constantly communicates with the others. Instead of forcing 4 wheels to behave as one, the vehicle controls each wheel individually, hundreds of times every second. In other words, the car isn't behaving like a traditional machine, it's behaving like software. That may sound like a small distinction, but it's actually one of the biggest changes happening in the auto industry. For more than a century, car companies competed by building better engines, stronger transmissions, and more refined mechanical systems. Now they're increasingly competing with algorithms. The hardware still matters, but software decides what that hardware can actually do. And once I understood that, the ET9 shaking off snow suddenly made a lot more sense. It wasn't an isolated trick. It was another example of the same idea. These vehicles aren't trying to redefine horsepower. They're trying to redefine what a car is capable of becoming. And the next Chinese EV would push that idea even further by removing something every car has had for more than 100 years. The next Chinese EV challenged something that every car has had for more than a century: a rear window, or more accurately, the lack of one. The car that removed the rear window. The first time you see the Avatar 12 from behind, something feels wrong. You keep looking, trying to figure out what's missing. Then it hits you. There isn't a rear window. For more than 100 years, every driver has relied on a sheet of glass behind the cabin. It has always been considered essential. Without it, how could you possibly see what's behind you? Chinese engineers asked a different question. What if the rear window isn't necessary anymore? Instead of relying on glass, the car uses high-definition cameras feeding live video to a digital display inside the cabin. At first, it sounds risky, maybe even unnecessary, but removing the rear window creates unexpected advantages. The roof becomes structurally stronger, aerodynamics improve, rear seat headroom increases. The driver gains a wider viewing angle than a traditional mirror could ever provide. Suddenly, removing something doesn't feel like a compromise. It feels like an upgrade. That idea kept appearing again and again. Instead of asking, how do we build a better version of the old car? Chinese automakers increasingly seem to ask, what parts of the old car do we no longer need? That is a completely different design philosophy. The missing rear window isn't really about visibility, it's about trust. For over a century, drivers trusted mirrors. Tomorrow, they may trust software. The same cameras that replace the rear window can also recognize traffic, measure distance, detect pedestrians, record accidents, and continuously improve through software updates. The window isn't disappearing because engineers ran out of glass. It's disappearing because cameras can perform multiple jobs at once. Once again, the hardware becomes less important than the software controlling it. And by now, a pattern had become impossible to ignore. The ET9 used software to solve winter. Firefly used software to rethink refueling. The Yangwang used software to rewrite vehicle dynamics. Now the Avatar was using software to replace one of the oldest components in automotive history. Different cars, different companies, different price ranges, yet they were all moving in exactly the same direction, toward vehicles that behave less like machines and more like intelligent computers on wheels. That realization finally answered a question I had been asking since the beginning. These companies weren't competing to build better cars, they were competing to build better platforms. And platforms become far more powerful when they're connected together, which led me to the biggest discovery of this entire investigation. The real product isn't the car. At first, I thought I was investigating cars. Then I started following the batteries. That's when the entire story changed. Battery swap stations, charging networks, battery factories, mineral processing, cloud software, artificial intelligence, robotics. None of these things are exciting enough to appear on a thumbnail, but together, they're what make every impressive Chinese EV possible. Take away the battery network, and the 3-minute battery swap disappears. Take away advanced software, and the self-shaking suspension becomes impossible. Take away robotics, and mass production becomes slower and more expensive. The car is simply the most visible part of a much larger machine. American consumers usually compare vehicles one against another. Tesla versus Ford, Ford versus GM model against model, price against price, horsepower against horsepower. China appears to be competing differently. Instead of building one great car, it has spent years building an ecosystem where batteries, software, factories, robotics, and supply chains reinforce one another. Each improvement makes every future vehicle stronger. Each new factory lowers production costs. Each software update improves millions of cars simultaneously. Each additional battery swap station increases the value of every compatible vehicle already on the road. That's an advantage that's difficult to measure on a specification sheet, because the product isn't just the vehicle anymore. The product is the entire system surrounding it. And once I saw that, America's decision started to make a lot more sense. Why Canada opened the door. Once I stopped looking at the cars themselves, another question became impossible to ignore. Why Canada? Why were these vehicles appearing on Canadian roads, but not American ones? Part of the answer comes down to priorities. Canada wants more electric vehicles on the road. More competition usually means lower prices. Lower prices make EVs accessible to more families. For Canadian consumers, another automaker entering the market simply means more choices, more technology, and potentially better value. From that perspective, Chinese EVs aren't just foreign products. They're another option competing for customers. The United States looked at the same vehicles and reached a very different conclusion. American officials weren't simply asking, is this a good car? They were asking, what happens if these cars become too successful? The United States already has enormous investments tied to its own auto industry. Millions of jobs, thousands of suppliers, entire cities built around automobile manufacturing. Companies like Ford, General Motors, and Tesla aren't just businesses. They're part of America's industrial foundation. Allowing heavily competitive foreign EVs into that market could reshape the industry faster than many policymakers are willing to accept. Suddenly, this wasn't just about consumers buying cars. It became a question of industrial strategy. What America is really protecting from the outside, tariffs look like taxes, but tariffs often tell a much bigger story. Governments don't usually impose major trade barriers because one product is bad. They do it because they believe that product could fundamentally change their domestic market. That's why this debate extends far beyond automobiles. It touches manufacturing, technology, supply chains, critical minerals, artificial intelligence, and long-term economic competitiveness. The vehicle itself is only the visible part. Behind every Chinese EV stands a massive industrial network capable of designing batteries, producing electronics, writing software, and manufacturing at extraordinary scale. That's the system America is evaluating, not just the car. Think back to everything we've seen, a luxury SUV that shakes snow off itself, a $16,000 EV with 3-minute battery swaps, a sedan that spins like a tank, another that removes the rear window entirely. Individually, each innovation is impressive. Together, they tell a completely different story. They're evidence that Chinese automakers are no longer trying to catch up. They're trying to redefine the next generation of automobiles. Whether they'll ultimately succeed remains an open question, but ignoring what they're building would be a mistake. Because innovation doesn't stop at national borders. It continues whether competitors are watching or not. Belief shift. At the beginning of this video, it looked like we were simply counting down 10 fascinating Chinese cars that Americans can't buy. Now the picture looks very different. The ET9 wasn't really about shaking snow. Firefly wasn't really about a low price. The Yangwang wasn't really about horsepower. The Avatar wasn't really about removing a rear window. Each vehicle was pointing toward the same conclusion. The real competition isn't between one Chinese automaker and one American automaker. It's between two completely different automotive ecosystems. One focuses on improving individual vehicles. The other is rapidly building an interconnected system of batteries, software, robotics, manufacturing, and infrastructure designed to make every future vehicle stronger than the last. Whether America eventually opens its market or keeps these vehicles out is a decision for policymakers. But one thing is already becoming clear. The future of the auto industry won't be determined only by who builds the fastest car or the cheapest one. It will be determined by who builds the strongest ecosystem behind it. And that's why this story was never really about 10 Chinese cars. It was about the future of the global automotive industry and the race that has already begun.